In this video, we're going to take a look at points of intersection for parametric curves. So when we're working with parametric equations, we need to be able to find points of intersection. So what we've got here is this question. It says that the curve C has parametric equations. We can see the equations defined here below. So we're asked to find the coordinates of the point where the curve C meets the x-axis. So where this curve here, C, would meet the x-axis, let's just make a note of this here. Where this meets the x-axis here, that tells us that we're looking for where y equals 0. Okay. What we're going to do now is set y equal to 0 here. So in that case then, 1 plus t is equal to 0. And in that case then, we obtain that t is equal to minus 1. Okay. So if t is equal to minus 1, what I can now do here is substitute that into this equation here for x. So x equal to t minus 4. But if t is minus 1, then in that case, x is equal to minus 1 minus 4. We simply get minus 5 there. And from here now we simply got the coordinates here. So the coordinates here, so the coordinates are, so our x coordinate here is minus 5. Don't forget the y coordinate here would simply be 0 because it meets the x-axis here when y is equal to 0. Okay, and there we have it. So the coordinates here are minus 5 and 0, giving us a solution to question 1. Moving on to question 2 now. So we've got the curve C here, which has parametric equations, which we can see defined here below. And we're asked to find the coordinates of the points where the curve C meets the y-axis. So let's just make a note here. Where this meets the y-axis, or meets the y-axis here, and this is where x equals 0. So almost identical to the previous question now. Rather than setting y equal to 0 here, we're now setting x equal to 0 because we're looking for where it meets the y-axis. In this case here now, we set x equal to 0. We get t squared minus t minus 6 equals 0. Like so. So what we've got here is a quadratic. So what we want to do now, if we can, is factorize. So can we factorize here? Well, in this case we can. We're going to get t plus 2. And we're going to get t minus 3. And this is all equal to 0 here. So in this case now we get two solutions here for t. We get that t is equal to minus 2. We also get that t is equal to positive 3. Okay. So from here now we've got the two solutions for t. So now we can find the coordinates here. What we need to do now is substitute both of these values of t here into y. Okay. So in that case then, when t equals minus 2, y is equal to minus 2 cubed, and then minus the 1 here. I'm going to get minus 8 minus 1, and that would give me minus 9. We get minus 9 there. And we do the same here when t equals 3. When t equals 3, y is equal to t cubed minus 1. So that's going to be 3 cubed minus 1. 3 cubed there is 27 minus the 1. That gives us 26 there. Okay. So in this case now, we just finish over here. Our coordinates here. The coordinates are, we're going to have 0 and minus 9 here, 0 and minus 9, and we've also got 0 and 26 here. Okay, and there we have it. So that's the solution there to question 2. And finally then, if we take a look at the very last question here, question 3, we've got the curve C, which has parametric equations of x equals t squared minus 3 and y equals t minus 1. We're asked to find the coordinates of the points of intersection between the curve C and the straight line wave equation 2y equals x minus 2. So what I'm going to do to begin with here, I'm going to take these parametric equations, I'm going to substitute those into this equation here. So for example, 2y, that would be 2 lots of t minus 1. 2 lots of t minus 1, that's equal to x minus 2, or x equal to t squared minus 3 here. We get t squared minus 3, don't forget the minus 2 as well here. So now we just simplify here, expanding the single bracket here on the left hand side, we'll get 2t minus 2, and that's equal to t squared minus 5 there. But what I notice here now is we're going to get a quadratic equation here. And what I'm going to do then is set that quadratic equation equal to 0. On the left hand side here, I'm going to subtract 2t off both sides and add 2 as well to both sides here. In that case, I'm going to get t squared minus 2t, and then minus 5 plus 2, and that would give us minus 3 here. And that's now all equal to 0. So because I've now got this quadratic here equal to 0, we want to see if we can factorize this here. And in this case, we can factorize. What we're going to get here is t minus 3. I'm going to get t plus 1 here. And that's all equal to 0. So from here now we get two solutions. We get t equals minus 1. And we get t equals 3. And what I'm going to do now is take these two solutions for t here, substitute those into our parametric equations here to get the coordinates of the points of intersection. So when t is equal to minus 1, when t is equal to minus 1 then, x is equal to minus 1 squared minus 3. So x is equal to minus 1 squared minus 3. So minus 1 squared, that would be 1, minus 3, so that would be minus 2. And now if we find the y coordinate here, then y is equal to t minus 1. So it would be minus 1 here, and in that case we're going to get minus 2 as well. When t is equal to minus 1, the coordinates of the points of intersection for this point here, that would be minus 2, minus 2. If we just repeat this now, when t equals 3 here, we'll get our final point of intersection. So when t is equal to 3, then x equal, so that's going to be 3 squared minus 3, so 9 minus 3 there. That would give us 6. And then for the y coordinate here, it's going to be t minus 1. So if t is 3, we get 3 minus 1. Giving us 2 there. In that case now, the coordinates here are 6, 2, and there we have it. So that's the coordinates there for the points of intersection. That's the solution there to the very last question, question 3. That brings us to the end of this video on points of intersection. In the next video, we're going to take a look at modelling with parametric equations.